Our story begins about 4.6 billion years ago. Imagine a vast dark cloud of gas and dust drifting through the cosmos. This cloud, called a nebula, was the birthplace of our solar system. The nebula, a chaotic mix of hydrogen, helium, and remnants of long-dead stars, swirled and churned. Then, something extraordinary happened. Perhaps a nearby star exploded, sending shockwaves through the nebula. This disturbance caused the cloud to collapse in on itself. As the cloud contracted, it began to spin faster and faster like a figure skater pulling in their arms. At the center of this spinning cloud, gravity pulled most of the material inward. The pressure and heat became so intense that hydrogen atoms began to fuse, releasing unimaginable amounts of energy. Our sun, a brilliant star, was born.
While the sun blazed at the center of the newly formed solar system, the remaining gas and dust continued to circle around it. This material, remnants of the original nebula, swirled and collided in a chaotic cosmic ballet. Over millions of years, these particles began to stick together, forming larger and larger clumps called planetesimals. These planetesimals, some no bigger than grains of sand, others the size of mountains, continued to collide and merge. Their gravitational pull attracted more and more material, eventually forming protoplanets, the precursors to the planets we know today. One of these protoplanets, destined to become our home, formed in the habitable zone, the perfect distance from the sun for liquid water to exist. This protoplanet, still in its infancy, continued to grow, pulling in more material and clearing its orbital path, eventually becoming the Earth.
The early solar system was a chaotic and violent place. Collisions between protoplanets were common. Earth, still in its formative stages, experienced one such collision that would forever change its destiny. A Mars-sized protoplanet, which scientists have named Theia, slammed into the young Earth. The impact was cataclysmic, melting both bodies and blasting molten debris into space. This debris, caught in Earth's gravitational pull, began to orbit our planet. Over time, this orbiting debris, bound together by gravity, coalesced to form our moon. The impact also tilted Earth's axis, giving us our seasons, and sped up its rotation, shortening our days.
In the aftermath of the moon's formation, Earth was a fiery inferno. Its surface was a molten sea of magma, constantly bombarded by asteroids and comets. But over millions of years, Earth began to cool. As the planet cooled, heavier elements like iron and nickel sank towards the center, forming Earth's core. Lighter elements like silicon and oxygen rose to the surface. This process, called differentiation, created Earth's layered structure. The outermost layer, the crust, began to solidify, forming the first solid landmasses. Volcanoes erupted, spewing gases and molten rock into the atmosphere, shaping the early landscape. The stage was set for the next chapter in Earth's story, the formation of oceans. The early Earth's atmosphere was a toxic mix of gases, including water vapor. As the planet continued to cool, this water vapor condensed, forming clouds. Torrential rains began to fall, lasting for millions of years. These rains filled the low-lying areas on Earth's surface, creating the first oceans. Water, essential for life as we know it, was now abundant on our planet. Some scientists believe comets, icy remnants from the early solar system, also contributed to Earth's water supply. These early oceans were not the pristine blue we see today. They were likely a murky brown, filled with dissolved minerals and bombarded by intense ultraviolet radiation from the sun. But despite these harsh conditions, life would soon emerge in these primordial waters.
The exact details of how life began on Earth remain a mystery. However, scientists believe that life arose in the early oceans, perhaps around hydrothermal vents, which spew hot, mineral-rich water from the ocean floor. These vents could have provided the energy and nutrients necessary for the first simple life forms to emerge. These early life forms were single-celled organisms, similar to bacteria. They were able to survive in the harsh conditions of the early Earth. Over millions of years, these single-celled organisms evolved and diversified. They developed new ways to obtain energy, eventually leading to the evolution of photosynthesis. And one of the most significant events in Earth's history was the evolution of photosynthesis. This process, used by plants and some bacteria, harnesses sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. The first organisms to evolve photosynthesis were cyanobacteria, also known as blue-green algae. These microscopic organisms thrived in the sunlit waters of the early oceans. As they released oxygen as a waste product, they began to change the composition of Earth's atmosphere. Over millions of years, oxygen levels in the atmosphere slowly increased. This had a profound impact on life on Earth, paving the way for the evolution of more complex, oxygen-breathing organisms.
Today, Earth stands as a beacon of life in the vastness of space. Our planet's journey from its fiery birth to its current state is a testament to the power of cosmic forces and the resilience of life. From single-celled organisms in primordial oceans to the complex web of life that exists today, Earth's story is one of constant change and adaptation. As we look out at the cosmos, we're reminded of the preciousness and fragility of our home. It is up to us, the current caretakers of this planet, to ensure that Earth's legacy of life continues for billions of years to come. Let us strive to understand and protect our planet, so that future generations can marvel at the wonders of this blue planet teeming with life.